Drawing and Design CU Purlin Machine. This process involves several key stages, which are explained step by step below, along with the necessary software tools, equipment, and technical expertise. We begin by defining the requirements. These include precise dimensions of the profile such as length, width, thickness, bends, and angles, as well as the intended application of the profile, and whether punching or perforation is needed. For example, in this video, we focus on the design and drafting of a CU profile, which is used in the construction of solar panel structures. In the next step, we move on to designing the flower pattern of the desired profile. The flower pattern is a progressive representation of how the final profile is formed through continuous bending stages. This pattern serves as the foundation for designing forming dies. At this stage, we must consider several critical factors, such as the bending rules in roll forming, the principle of gradually dividing, bend radii across stations, minimizing springback, maintaining cross-sectional stability during forming, and preventing wrinkling or wobbiness in the profile, all to ensure the highest possible product quality. In roll forming machine design, we use software tools such as Copra RF, Kasha, Abacus Software, AutoCAD, and Roll Forming Designer. These programs assist in 3D modeling, simulation of forming processes, and generating precise technical drawings for both the profiles and the forming stations. When designing the rollers, we consider key factors such as optimal engagement between the rollers and the sheet to prevent slipping, shaft diameter and bearing type to withstand axial and lateral forces, and roller geometry that matches each stage of the flower pattern. We use high-strength alloys such as CR12 or CR12 MOV to ensure that even after years of operation, the rollers maintain their shape and the product quality remains consistent. Additionally, for machining these rollers, we use advanced CAM software such as MasterCam and PowerMill to achieve high precision. In the mechanical design of a roll forming machine's chassis, several aspects are considered, such as the use of steel beams, drafting of roller support shafts, gearboxes, power transmission components like chains or couplings, roll stands, cutting guillotines, and punching systems. Important considerations include managing bending and torsional loads on the frame, minimizing shaft deflection, selecting suitable motors, and designing effective cooling and lubrication systems for controlling the machine and its drive systems. We use AC or servo motors, inverters, position sensors, indicators, and an intelligent PLC-based control system. Thank you for watching our video. Be sure to turn on notifications and join us in the next videos to learn more about the roll forming process and the design of each of its parts. Don't forget to like, comment, and subscribe.